In today's video, we'll be drawing the reaction mechanism of the Curtius rearrangement, which is similar to Hoffman in that they both create isocyanate intermediates. But the difference is one starts with an amide and the other starts with an acyl chloride. Their reagents are also different, but in the end they both produce a primary amine with the carbonyl carbon lost. So in the first step of a Curtius rearrangement, we begin with a regular nucleophilic substitution with our sodium azide as the nucleophile, which has 3 charges. And this is not in equilibrium. So now only 2 of the nitrogens are charged. This kicks out a leaving group. Now is where things get different because we want to create an isocyanate. We will treat this in some heat so that it will rearrange. So we want a double bond between carbon and nitrogen. So we can use the lone pairs, push this over here, and we want R group attached to nitrogen. So this is our R group. We push this bond here, and we want to break off this entire chunk. So we use this alkene to attack the neighboring positive nitrogen, and that will give us the isocyanate. Okay, so now that was the first and second step. First step, nucleophilic substitution. Second step, heat to rearrange for isocyanate. Now third step, is that we want to get this as our leaving group. So we will start by using water in the solution to attack the area of positive electron density. Now this is attached to a protonated water and a negative O, but this is imbalanced, so we will balance it by doing a hydrogen transfer. So this gains an H and this loses an H. We get 2 alcohols. Now the rest of the 2 steps is that the alcohol will attack the carbon. Alcohols, lone pairs, attack carbon, and to respect the leaving group of carbon, we have to break off this bond between N and C. And essentially, we will do that twice to get our amine leaving group. So this is now a carbonyl. And we just have to do that again with the other alcohol. Attack carbon, right? The carbonyl carbon, very positive. So then that will split off our bond on the N. Oh, and this gets protonated as well, this one. So this will also get protonated to make itself a better leaving group, right? So now we get this split off. This is our leaving group. And we also get carbon dioxide. So major takeaways is first step of Curtius rearrangement is nucleophilic substitution. Second step, use heat to make isocyanate. Third step is to use water to attack the carbonyl carbon to get 2 alcohols that used to be a negative O and a positive OH2 plus. We do a proton transfer so that we get 2 alcohols, and the lone pairs on the alcohols will attack at the carbon and do that twice to remove the primary amine as a leaving group, making sure to protonate your amine in each successive step.